I was on a job site visit a few years ago on a small packaged unit. And when I got to the job site, the homeowner told me, "Our unit has never heated the home, and it made a loud swishing sound all winter." As soon as they started up the unit, I knew exactly what it was. The swishing sound the homeowners heard, and the noise that the techs who had been on this job previous had heard and misdiagnosed, was the internal pressure relief valve releasing and allowing pressure to go from the high side to the low side. When the IPR valve opens up, the compressor does no pumping of refrigerant at all. And so, of course, the unit did not heat the home. They did have heat, however, because the heat strips had run all winter long. Another device internally on compressors which has caused misdiagnosis of a good compressor is the internal overload. When this opens due to high temperature, when you ohm the compressor, it is going to show as an open winding. And many technicians over the years have condemned a perfectly good compressor because the internal overload had opened up. In the previous slide, we showed the internal overload depicted electrically on the wiring schematic. This picture shows where the overload is embedded into the motor windings, and it shows what type of switch it is. When the motor overheats, either because of lack of refrigerant or from some electrical problem, this overload switch will open. Then later, as the compressor cools off, it will switch closed again. And if the problem with the refrigerant or the electrical supply to the compressor has been solved, the compressor will probably run for quite some time. This picture depicts a water hose on the compressor, running cool water over the compressor to cool it off. During my time in the field, there were many times that I would go to a local 7-Eleven store and buy a bag of ice to put on the top of the compressor to cool it off. Working in the hot Arizona sun, it would take quite some time for compressors to cool off. So sometimes methods like this, either running water over the compressor or putting a bag of ice on it, are needed to get the click-on switch to close inside the compressor so you can get it up and running again. As I mentioned, I worked in the Arizona region for quite some time, and one thing that I remember is that when we used to eat our lunch out in the warehouse, we'd be sitting there eating lunch, and we would have these skids of compressors that had been returned sitting in the warehouse. And as you would sit there eating lunch in the cool warehouse, you would hear click, 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 click. All these overloads on these compressors as they were sitting in the warehouse out of the sun and the heat, the overloads would start closing. So there were many compressors that were condemned because the overload was open, but there was nothing mechanically or electrically wrong with the compressor. So with this video, we just wanted to make sure that you understand the protection that a compressor has internally that is not seen unless you look at it on a wiring diagram or on a breakdown of the compressor. The IPR valve on the left will open whenever the high pressure reaches a point that will release the IPR valve and allow high discharge gas to bleed over into the suction side. When this happens, there will be no pumping that the compressor will do. The second one, the one on the right, is your internal overload, which is embedded in the motor windings of the compressor. And when the compressor overheats, this switch will open up and it will show as an open winding. So make sure you don't condemn a compressor that has one of these issues going on, but otherwise is mechanically or electrically just fine.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.